Good morning and welcome to another Fusion Friday. My name is Alex Alvarez, Application Engineer here at T Technologies. So happy Friday, everyone. Hopefully we've all been having a pretty good week so far. Again, if you guys are located in Southern California, you're probably recovering from a little bit of rainfall these last couple of days. Pretty tough times, right? Where we get excited over a little bit of rain, or at least I get excited. So anyways, for today, we are going to be talking about sheet metal. Now, sheet metal specifically inside of Fusion 360, right? So that's the topic that we are seeing more and more come up in our surveys. So again, we wanted to answer some questions, really clarify some confusion around that topic, right? So again, if you guys are new to these webinars, it's a series of webinars where we go over all the environments that Fusion 360 has to offer. So again, we don't like to just focus on just one specific topic. We really like to cover, the entire spectrum from design and manufacturing, and really show you guys that workflow and what that looks like, right? So again, for today, the why for today is going to be exploring the sheet metal environment inside of Fusion, breaking down the workflow from the sheet metal design, sheet metal component, to actually generating some sort of tool path, right? So whether you're going to be controlling your water jet, your laser, your plasma machine, how does that look like, right? Creating some sort of nesting of that component inside of a specific sheet size, and then getting that ready to manufacture, right? And then, of course, observing some sheet metal practices by going through a real world design problem, right? So here we have the power supply enclosure. Again, we're just going to focus primarily on the this component here. This is comprised of two components, but again, just to make things relatively easy and a little bit quicker, we're just going to focus on this one here. Again, so let's go ahead and jump right in and take a look at how that looks like.
Oops. Okay, sorry guys. It looks like we had some audio issues there. Let me see if I can fix the mic real quick. Okay. All right. Okay, so let's go ahead and jump into Fusion 360 here. Again, if you guys are new to the software, pretty straightforward, right? So again, we're going to have the essentially our model environment here. We have our ribbon. If we go over here to the very top, notice that we can switch between different environments, right? So let's see if we switch the environments here. Notice that you can switch the workspaces, and again, if we go into the sheet metal environment, we have a completely different tool ribbon. Okay, so if we, again, go back into the model environment, notice that the commands start switching a little bit, right? So over here on the left, again, if you guys aren't familiar with the Fusion 360 environment or just the software itself, this is where our data panel is going to be at, right? So again, we have all of our models. We can store them with different projects, right? So the way I like to work in projects, again, if we click on the a specific project, I like to organize them based off of a specific customer, right? So if I'm working with a customer, I create a project for them. I start storing some of that data inside of that project. And what that allows me to do is if I go over to the People tab, notice that I can start inviting people to that specific project, right? So again, that eliminates the need to really send any data or start exporting data or send files, set up some sort of Dropbox, right? So again, have everyone that's going to be working on a specific project or really collaborate on a model or on a project, just invite them to that project, right? And then have them or give them access to all the models, all the data that you're going to be working with inside of there. So again, let's go ahead and start working with that power supply enclosure that we were talking about. Let's go ahead and switch right into the sheet metal environment then. That's what it's going to be comprised of, right? So let's go ahead and close the data panel there just so we have some more real estate. So right inside of the sheet metal toolbar, notice that we have a few options, right? So we have the sketch commands. We have the create, which has a few sheet metal commands, but really not a lot, right? We just have the component, flange, the drive, right? So if you start off with the body and you want to then later on down the road create a sheet metal component out of that solid body, you can do that based off of some sheet metal rules that you have specified, right? And of course, you're modeling your modeling commands here as well, right? And then right next to that, we have the modify dropdown, right? So creating flat patterns, fillets, chamfers. Really the most important one here is going to be the sheet metal rule, right? So that's what's going to be driving the assembly or the model that you create based off of a sheet metal rule that you have, right? So if we click on that, notice that it brings in the sheet metal rule here. Now I already have a stainless steel 11 gauge material selected. For whatever reason, if you start with a specific rule and then maybe halfway through you decide, okay, maybe that material isn't going to work for me, you can always go ahead and create a new rule and then set that as the new rule for your model, right? So it is going to change that. You're not really just confined to a single rule throughout the entire modeling process. You can switch rules in between, the design. So in here, what you can do is you can always right click, you can edit the rule, you can create a new rule based off of, some previous ones, some default here. But as soon as we hit the drop down, notice that we have a few options, right? So you can set the thickness, set the K factor, right? So we go a little bit deeper dive into this topic in a previous webinar. But again, if for whatever reason you want to learn a little bit more about that, feel free to reach out to us and we'll gladly explain what the K factor is. But for now, let's just go ahead and focus on just the actual design and manufacture of this. You also have the bend conditions, right? So how are these bends going to come together when you fold these flanges? Are they going to be round? Are they going to be some sort of a tear cut? Again, you can start defining all of this inside of this specific sheet metal rule, right? Again, so you have a few parameters in here that you can really set to your standards or whatever your customers are requiring. And then this is always going to be your first step, right? So start defining your sheet metal rule, and then that's going to dictate how your design is going to come along. Okay, so let's go ahead. Again, I set the 11 gauge as default. So now what I want to do then is I want to start creating some sort of profile for this, right? So let's go to Sketch, Rectangle. Notice that I have an R right next to the center rectangle, right? So this might be a little bit different for you guys, and that's because I set the center rectangle to have that hotkey, right? So if you guys aren't new or aren't aware of the hotkeys, you can click on these three dots and then change that keyboard shortcut, right? So again, you can customize your own hotkeys and then set that to be, whatever hotkey you want it to be. So again, if I hit R on my keyboard, brings up that center rectangle, and I'm going to start on the front plane here, right? So again, I'm going to do some sort of a arbitrary rectangle, and then D for dimension, and I'm going to start giving it some sort of dimensions here, right? So 4.5 by 6.5 here. Okay, so if you're coming from, let's say, Inventor, right, and you're accustomed to their sheet metal work or the sheet metal environment over there, you'll notice that you typically start off with some sort of a face command, right? So if we go to create, we don't see that face command in here. And really the flange command is what's going to be driving the entire sheet metal part. So it's going to be responsible for creating those faces. It's going to be responsible for creating a flange, a contour flange, and even hems, right? So I'll show you how you can create a hem towards the end of the webinar. But really that flange command is really what's going to drive the entire sheet metal part, right? So again, let's start off with that, create the flange, and it creates that flange, right? So we take a look at it, we see that it gets created based off of that stainless steel 11 gauge rule that I used. And I'm going to be fine with that, right? So let's go ahead and click OK. Creates a new body. Now, one very important thing to remember is you have to kind of start thinking ahead, right? So is this going to be a one-off part? Are you going to maybe use this in assembly and this is going to be just one component out of multiple components in an entire assembly? And are you going to be creating that assembly in this specific file? So if that was the case, what you want to make sure that you do is if you go over here to create, you want to make sure that you select new component, right? So again, always going back to the golden rule, you don't want to start off with a solid part as the parent file. You want to make sure that you have essentially kind of a clean slate at the top level, right? So again, the top level node should not be a part if it was going to be an assembly. And you want to make sure that you create components and make those components, the components that are going to be driving your assembly. In this case, though, it's going to be just a one-off part. I'm going to be adding this to a separate assembly, so we really don't have to worry about, creating a new component for it. Okay, so moving along here, let's go ahead and create another flange, right? So we're going to work on the sides here. Now, it is pretty important on which edge you select, right? So what I mean by that is if I select the outer edge here, that means the flange is going to get created towards me, right, or towards the left over here. If I click on this edge, notice that I automatically get an arrow, and it wants to create that flange towards the right, right? So if I click on, you can select multiple edges here, and you can start dragging them, and it creates them towards the right, right? So if I try to go the other way, notice that it doesn't let me, it kind of stops there. So the only option then is go that way, right? So here we have the flange dialog box, right? We'll talk about these in a little bit in a couple more minutes. But for now, let's go ahead and focus just on these bottom options, right? So again, you have the height, right? So essentially controlling the distance from that front face, and the height datum, right? So is it going to be from the outer face, or do you want to control the height from the inner face over here? You have some flexibility, right, in kind of dictating what that's going to look like. I can leave it as outer face, and then the bend position, right? So that's going to be pretty interesting. So if we take a closer look at the front here, notice that I'm going to hold Control on my keyboard and take a look at what that did, right? So here's the edge. Notice that then the bend or the edge is going to serve as the outer boundary for that bend, right? So again, it's essentially confining it to that edge that I selected. Maybe that wasn't the case, right? Maybe you want to measure that from the inside of that edge, or you want that to bend from the inside of that. So what you can do then is set that to outside, and now you can start seeing where it starts bending from, right? Again, you have a few other options, right? So adjacent, so that's if you truly wanted, to bend from the outside there. So if we take a front view look, notice that we have the edge here, and notice that the bend then starts right next to that edge that I selected. Right, so again, that's all going to come down to how it was designed and how the drawing was created. But for us, we're going to be fine keeping it from the inside. Right, and then again, if you wanted to override the rule, you can. I don't suggest it, right, because again, you want to stay consistent throughout your entire design. But if you did want to, or there are scenarios where you do need to override the rule, you can have that option in there, right? So for this one, let's go ahead and just give it a height datum or height position of 6.75. Click OK. And let's go ahead and create now the top, right? So the top and bottom flanges here. Again, I don't want to go all the way to the top. I can just right-click, repeat flange, and start selecting the edges that I'm going to select, right? So again, if you click on a wrong edge, you can control and then unselect. So I want to go ahead and select these inner edges, these last three here. There we go. And then drag them towards the inside, right? So that's going to be the only, essentially the only direction that I can pull in, and I want to make these 1 inch, right? Okay, so if we looked at the model, we can tell that the flange over here, or at least the top and bottom flanges, weren't going all the way, right? So again, we want to essentially stop that prior to reaching, the end of that part there. So I want to go back over here to the top, right? So going to the full edge options here, and you want to start figuring out which edge belongs to which flange, right? So again, if I click on each individual one, you can start seeing which edge was selected, right? So notice that edge 1 is going to be the one that we want to focus on. And what you want to do then is hit the little drop down, and you have a few options here, right? So do you want that edge to be symmetric? In this case, we don't, right? Because otherwise, if we pull this back, it's going to pull back from the front as well. Instead, what I do want is a 2 offset, right? So I don't want an offset here, but I do want some sort of an offset from the back, right? So if we take a look at what's happening there, let's go ahead and rotate this around. notice that now it created the flange, but it doesn't extend all the way, right? And right where it stops, it creates that little that relief cut based off of whatever I have in my rule, right? So again, I can say I want an offset of, I don't know, 3/4 of an inch, and now do the same thing for edge 3, right? So instead of full edge, do a 2 offset, and then do minus 0.75, right? So again, we can kind of drag this back here a little bit. Minus 0.75. Okay, and that's just going to apply to the top here. So let's go ahead and select OK. And we have our model here, right? So again, I want to remind you guys, if you have any questions, if there's something that you didn't quite understand, feel free to ask away, right? So I'll do my best to kind of answer along as I'm going through it. But if I don't get to it, I will answer at the end of the webinar, right? So let's keep moving forward here. The next step would probably be some sort of a cutout over on the top and bottom, right? Just so that we have a little bit of tension on the top component. So let's go ahead and create that cutout, right? So again, I want to start off that rectangle, center rectangle in this case. So I can just hit R on my keyboard and select that top face. Now, really, all I'm going to care about in this cutout is the width of the cut, right? So I can just do D for dimension, and I just want that width to be 1 inch. And then using my modeling commands, E for extrude, and give it some sort of cut depth, right? Now, typically when you're working with sheet metal, especially if you're coming into or from Inventor, notice that if you're working with the sheet metal cut, it usually goes or defaults to the thickness, right? So the thickness of the material is the kind of cut that you're going to be working with. So if we try to type thickness, take a look at what happens, right? So it turns red. It's saying that, hey, that parameter doesn't exist. Go ahead and change that value, right? So let's take a look at what's happening then. If we go to modify, change parameters, right? Notice that we don't see any parameters in here, but we do have this sheet metal rules parameter, right? So hit the drop down again. So this is the rule that we have actually. So we do have a parameter that's called thickness, but take a look at what's being referenced, right? So this D3 name is what's being referenced. So again, if you ever wanted to, if for whatever reason you change this rule down the line, and it becomes a different gauge, you want to make sure that that changes, or that cut changes along with whatever value you have in here as well. So if we once again go into the extrude command, this time instead of typing in thickness, what you can do is I want to do 2 times the thickness, so -2 times D3, right? And then hit OK. Notice that that command actually took that D3 value, right? So again, going to our flange tool, selecting that inner flange, and then just extending it 1 inch. Okay, so we have those cutouts. Again, I don't want to go through that entire process for the bottom, so let's go ahead and just mirror those 2 features that I just created. S for the sheet metal shortcuts, MIR. What do I want to pattern? I want to pattern the features, and then select the 2 features that I just created, right? As soon as I select mirror plane, it brings up the origin here. Again, this is a common question I get, right? So a lot of people try to rotate their models and then try to select that plane there. And that's okay, but sometimes it's a little tight in here, and you can't necessarily do that. So again, the quick tip here is left click hold, and it brings up this dialog box, right? And then just select the XY plane. Hit OK. And it automatically mirrors that across the XY plane. So now we had some sort of a shape over here, right? That was essentially just patterned across the front face, and then the hole. So those are going to be really the last 2 features that we have. So let's go ahead and create those. Again, we want to go to Sketch. It's going to be a polygon in this case. Inscribe. And let's just create that arbitrary shape somewhere along these lines. There we go. We can say that we're going to have some sort of parallel constraint between these two edges. Maybe these two are going to be vertical. And then we can say, okay, maybe the entire length of this, or the cutout, is going to be 1/4 of an inch, right? And then now we have to give it some sort of dimension, right? So position this between the center and say that's going to be 1.7. And then the height is going to be 2 3/8 here, so 2.375. All right, go ahead and extrude cut that and say minus D3, right? So again, sticking with that thickness parameter that we had, right? So minus D3, and it gives us the cutout. And again, if this ever changes thickness, that cutout is also gonna change thickness along with it, right? So again, let's go ahead and pattern that. So once again, S pattern. What kind of pattern do we want? We want to use a rectangular pattern in this case. And again, we want to make sure that we pattern the feature, right? So a lot of people select faces, and what they have to do is then select the entire 6 faces that we had there. Just select the feature, and over here in your design history, just select the feature, and then which direction. I'm going to go in the X direction there. We're going to say 10 instances at 2.375. There we go. And then we'll say 10 inches or 10 instances at 3.5 down. Right? So there we can kind of see a quick preview of what's taking place. Again, notice that we have some check marks here, right? So what that means is you can always check some of these, and what that's going to do is it's going to suppress those specific instances, right? So we can do some of these. Maybe we don't want this one right here, right? So you guys kind of get the point here. You do have the option to suppress some of these. Again, you don't have to go back and hide something, or maybe try to edit that specific feature or cutout. Just do that inside of the specific pattern, and then let's go ahead and change that to optimize. And there we have our cutouts, right? So really, the last step here then is creating that hole. Right, so again, let's create that hole here. C for circle. And then notice also that I'm not having to create a flat pattern, right? Or unfold it and start refolding it. Again, I'm working on the same face that I started off with, so that's always going to be my stationary face. So I don't need to go back in here and create some sort of a unfold feature in order to create these cutouts, right? So this one, I believe is going to be 1.8. And then the X distance, I believe, is 1.325. There we go. All right, so it's now starting to take shape. And again, D3. Okay, so there's our final model, if you will. Again, it's pretty straightforward. You don't have tons of commands that you have to worry about. Really, the flange tool is what's going to be handling most of your sheet metal design. And again, it's pretty powerful, and you'll start seeing here towards the end of some of the things that we can do with that flange tool, right? But for now, really, we're pretty much done, right? So let's go ahead and unfold it just so that we can see how that looks like, right? So we go to modify, unfold. Our stationary face is going to be that front face. Unfold all bands and select OK. All right, so now at this point, we double checked it. We make sure that everything was correct. Now we're ready to essentially send it out to our plasma machine, right? So let's say we're going to get this, cut out on our plasma. Again, we already have some sort of specific sheet size. So let's go ahead and see how many of these we can essentially fit into that sheet size, right? Or the process, the workflow of how that looks like. First things first, you want to go ahead and save it. I'm going to go ahead and save, let's see, power supply. Right, so PS, go ahead and hit save. So now if we expand the data panel here, right? So notice that it's not in that specific project that I was looking in, right? Reason being is if you want to save this specific model in that project, it's always best practice to just have that project open. So therefore, when you hit save, it's going to automatically save into that project, right? So if you don't do that, if you just left it, somewhere out there, you can move it, or you can do a file, save as, and then just name it power supply, right? And then just make sure that you do save it inside of that specific project, and then hit save, right? So it brings it into its own project here. So now let's go ahead and start a new design, right? So we want to start an assembly, and again, we don't want to start that assembly here. So first, what you want to do then is save this specific assembly, and then just call it, give it some sort of a name. If you try to insert the components or insert it into the current design, you are going to get an error saying that, hey, you need to save the assembly first, and then give it some sort of a name to it. All right, so first step here then is going to be creating your stock. Notice that I do have mine already created, and what I can do then is insert that into the current design. So let's go ahead and do that. I'm happy with that. Go ahead and ground that stock component. Okay, so the next step is bringing your actual sheet metal component into the design here, right? So again, right click, insert into current design, and it brings in our component, right? So let's go ahead and pause here for a minute. Let me see if we have any questions so far. Okay. All right, so we have a question here. I want to know what projects using sheet metal. Can you dive into that? Okay, yeah, so perfect. Let's go ahead and start. Let's go ahead and start talking about that. Actually, so there is a nesting add-in that you can use, right? Again, if we go into the add-ins over here, go to the Fusion 360 App Store. This is where a lot of people start getting confused, right? So they'll see a nesting add-in, or some people using a add-in for that. So if we type in Nester, right, because that's the name of the add-in, notice that it doesn't come up in the App Store here, right? So again, you want to make sure that you go to your web browser here, type in Fusion 360 Nester, and it's going to be found in GitHub, right? So if you guys aren't familiar with GitHub, it essentially stores multiple, if you will, like programming projects. And so if people are starting up with some sort of program or maybe some sort of add-in, that's essentially where they can store or they can save some of those projects, right? So again, we have someone here that created this add-in. If we scroll down a little bit, notice that it is for wood, right? And I'll kind of talk about why I decided to go with this add-in or why I use it in the first place. But again, notice that it is specifically, or it's mostly designed for some sort of wood project, right, or for CNC routers. There is a README document, and it kind of walks you through how to install this into Fusion 360. You do have to install this into a specific folder. So again, if you guys need help, go ahead and email me. I'll be happy to kind of walk you through. We can even set up a call, and I'll walk you through on how to install this into your Fusion 360 add-ins. But again, you can make an account here. It's completely free. You can download it, and then from there, like I said, install that into your Fusion 360 folder. So once you do install it, what you want to do then is go to add-ins. Right? So if you go to scripts and add-ins, it's going to be found in here under your add-ins tab. Go to Nester and then just select run, right? So notice that nothing's going to happen. So no window appears, no little pop-up is indicating anything. But if you go back into add-ins, notice that you'll have that Nester command right underneath, right? So as soon as you click on that, you get this little window, right? So let me go ahead and close this out. All right, so now it's asking you for the base face, right? So again, what kind of base face or what stock face are you going to be using? I'm going to go ahead and click on that face and the other faces here, right? So again, I only have one component. What you can do actually is instead of creating some sort of flat pattern, is unfold the sheet metal components that you had, and essentially that as long as you have them in the same orientation, or you just have them inside of that previous drawing or model file, you can bring multiple files into a single sheet size, right? So again, I remember doing a sheet metal demo or a sheet metal webinar where I was using a flat pattern, and then I activated the flat pattern, and then I created some sort of CAM toolpath based off of that, right? So again, with that, if you want to go the route of a flat pattern, you can only have one active flat pattern at a time. But if you decide to go this route, you can unfold multiple components and then bring them all into the sheet size, right, or into the specific sheet. So again, I just have this single one, but it's going to essentially apply the same way as it would if you had multiple components in here. So let's go ahead and click on that face, right? What's the direction edge? It's going to be this edge here. Click OK, and it automatically places it on that specific sheet, right? So again, reason why I decided to go this route is because, again, notice what it's doing, right? So it's adding a few joints. It correctly placed it. And if I had multiple components, I would just select those individual faces, and it would automatically create joints for that, right? So instead of me having to create joints for each individual component, it's automatically doing that for me, right? So again, it's saving us time a little bit. What I can do from here then is start placing this, roughly in some sort of close position. And that's where I wanted to touch on, right? So this isn't a full automated nesting add-in. There isn't one yet for Fusion 360, so that's something that might get added on. I haven't heard too much information on, if nesting is ever going to get implemented into Fusion. But for now, this is something that gets you relatively close, right? So again, there isn't or those features that give you, the waste material, or it automatically places your parts or your components at a specific angle to minimize, waste. You do have to do that yourself, right? So I just wanted to make that clear. There is some manual labor that has to go into this when it comes to actually adding, your components to it. So again, we place the components roughly in the position that I want to start in. Now let's go ahead and add the other components, right? So I want to go ahead and right-click on that component, say Move Copy. If I try to move it, it's just going to move that component right now, right? So by itself. So again, if you want a little bit more finer control over the, maybe some sort of distances or locations, you do have the option to do that, right? So I can just drag and drop here. Notice that I have the arrows and start placing them a little bit more closely to the edge here, right? But if I wanted to create a copy, right? So if I go ahead and hit OK to that, if I wanted to create a copy, I can go over here to Move Copy. Notice that I have this Create Copy checkbox at the very bottom, right? So let's go ahead and create that copy and place it, again, somewhere around there, right? So again, you can give it some sort of a distance of a finite number if you wanted to be precise. So you do have that option, right? Again, let's go ahead and right-click on this, Move Copy. Oops. Right-click, Move Copy, and then don't forget to select the Create Copy there, right? So now if we drag it, now we can move it somewhere around here. We can rotate it, let's say 90 degrees. And then again, start dragging it into position here, right? So you guys can kind of see what I'm doing. Again, there is going to be some sort of manual labor, like I said. But again, it lets you see exactly what's going on, right? Instead of creating just a simple pattern of this inside the CAM environment, you can control it based off of copied models that you create. So from here, really, you can just go ahead and select OK. I don't want to fill out the entire sheet here. And now really what you have to do then is go into the CAM environment and start working on your setup, right? So again, we do have videos on a deeper dive inside the CAM environment. So for this, if you guys want to learn a little bit more, just go to our YouTube channel, and we have videos there kind of walking you through the CAM workspace here. But for now, let's go ahead and just create our quick setup. Notice that I do have my stock visible, right? So that's usually always going to be my first step, is go to stock. I modeled the stock, so it's going to be a front solid in this case. If I expand the CAM components, drop down here, it's always good practice to name your components as well, right? So stock component. And now what I can do is I can hide it, right? Because I don't want that to kind of interfere with the bodies that I have inside of the CAM environment. So now if I go back to my setup, this is going to be one of the most important or crucial steps, right? Is the bodies that you have selected. So essentially, this is telling the software what bodies are going to get cut out, right? So we only want these 3 bodies. Notice that we had the stock visible, so it automatically selected that. In this case, what you want to do is you want to make sure that you clear that out. You can select the components in here one by one. What I like to do just to make sure that I do click on the actual component itself is just click on them inside of the design tree over here, right? So there's our 3 components. Our WCS is not going to be in the center. It's going to be somewhere over here in the bottom left. Go ahead and click on that. And this is going to be also another crucial step, right? We aren't doing milling. We're going to be doing cutting, right? Or some sort of 2D profile in this case. And go ahead and click OK, right? So again, I kind of to reiterate what I did, I started with the stock tab, selected it from the solid that I modeled, came back to my setup. I selected the 3 components that I was going to essentially cut out. And then I set up my WCS, right? The nice thing about this too is that I didn't have to really reorient my WCS. So here's another quick tip, right? So if you guys, or by default, Fusion 360 comes with the y-axis pointing up. What that would have done then is I would have had to go into the WCS orientation, and then I would have had to reorient my z-axis, right? Because again, your z-axis is always going to be up and down if you're working with some sort of a laser machine, right? So again, if you want to make sure that that's always default, if you go to your name over here, preferences, notice that you have your default modeling orientation, right? So you have the Y up and the Z up. So again, if you do a lot of milling, or maybe you have a water jet or laser machine at your shop, typically you're going to want your Z to be up, right? So again, that's always going to be just the one step less that you can avoid when it comes to creating your setup here. But really, the last step here then would be to add the actual 2D profiles, right? So again, that's going to be found under cutting. If we go to the 2D profile, again, we notice that we have the same workflows, right? The same 5 tabs that we see if we're creating some sort of milling or multi-axis toolpath. Starting off with the tool, let's go ahead and select that. Again, we can go over here, create our own, kind of specify the kerf width, right, of our cutting tool. Or if you just want to make it extremely simple, if you go to the sample tools, notice that we have a sample profile. We do have that 40 thou plasma cutter. Again, you can always go back, edit that plasma or that kerf width, and change that to whatever kerf width your machine has, right? So again, cutting mode is going to be through auto. If your machine supports etching, you can do etching as well. For me, I'm just going to do a through cut. And of course, you can start specifying some of the feed rates here as well, right? And now we get to the fun part, right? So now we actually get to define some sort of contour or geometry for this part. What I can do then is I can go ahead and select this face, right? And what I want to do then is say, okay, I want to go ahead and select the same planar faces. So what that's going to do is it's going to automatically find all the contours that are on the same plane as the face that I selected, right? So by default, it's going to select the entire loops. In this case, maybe I just want the outer loops, right? So outer loops, and then say start on the outside, right? You can always say always on the outside. If you want tabs, you can go ahead and start defining the tab width, right? Maybe you want them to be, I don't know, 6 inches apart or every 6 inches, and then hit OK. Right, so it automatically creates that toolpath based off of some of the parameters that I set in there, and notice that it's always going to be starting on the outside. Right. Again, let's go ahead and duplicate that toolpath, and let's go ahead and do the cutouts over here in the middle. So Control D for that duplicate. So now we have 2 of the same toolpaths. Let's go ahead and edit that copy toolpath. So again, we're going to be using that same tool for geometry then. Let's go ahead and clear out some of the selections here. And this time I don't want to use the select same planar faces. This time what I want to do then is I just want to select the faces where all these cutouts are going to be taking place. And now instead of the outer loops, now I just want the inner loop selected. And I want that to always be inside, right? Always start on the inside of the cut because, again, it's going to be an inside cut, right? We're going to cut the inside profile here. I don't want any tabs in there. Again, heights, I honestly, when I'm working with the cutter here, I don't really change the heights. Passes, I also don't change that unless you need to change some sort of compensation, or if you want to use some sort of stock to leave here. The linking is really how it's going to lead into the part. So you might need to change the lead in sometimes depending on how small your feature gets. And again, you can do that. You can do that in here, right? Some machines do require a lead in radius actually. Again, in order for it to kind of shoot off or start the torch right away, it is going to need a radius in order to kind of fire that for the initial step, right? So if your machine isn't doing that, you might want to take a look at the lead in radius here. But really, other than that, we can just go ahead and hit OK. And it creates that toolpath now for the inside, right? Maybe you want to use, or maybe you want to cut the the inside cuts first and then the outside cut, which would probably make more sense, right? So you can just drag and drop your toolpaths. Now we have the inside cuts first, and then we go ahead and we cut the outside of the part, right? Okay, so now really the last step is going to be posting out to your machine. So let's go ahead and post process. Again, we already have the Mach 3 post processor in here. If you don't find it, or if you don't find your machine, you want to make sure that you go to the Autodesk HSM post library first. Again, you can quickly go in here, just click on that link, and change this to be water jet, laser, or plasma. Right? So then that's going to show really just all the laser or the water jet posts that Autodesk has available. They're not always listed on that dropdown. Again, they just upload them here, and then you can just download them. Again, if you need help with this, I have a kind of a walkthrough or a video showing you guys how to do it. Just let me know, and I can send that over to you guys. But yeah, again, if you don't see your post processor, just make sure you go to that HSM post library, and you look for it there, right? And as always, they do have a few user properties here built in that you can always go in here and change, right? But really, after this, you can just give it a quick program name or number, save it to some sort of location, and then post it out, right? Okay, so it's all fine and dandy, but what happens if maybe someone decides to make a change to the part, right? That actually happened to us last week, where a customer accidentally sent the wrong assembly, right? And that happens. We're all human. Unless you have some sort of automated process, you can't guarantee that files are always going to be spot on, or they're always going to be perfect, or they're always going to be the correct ones, right? So again, let's say for whatever reason, maybe the model here changed and they gave us a now dated version of it. Let's say that the previous one, instead of the 6.5 height, maybe it was supposed to be 8.5, right? So let's change that to 8.5. We can go ahead and stop the sketch. And we can right away see that it made a difference, right? Or that it actually extended the face here. Let's go ahead and save that. Now, this is going to be important too, right? You want to make sure that you keep those linked. If for whatever reason you broke the link, this wouldn't apply to that part anymore, right? So again, you want to make sure that you reference that specific model, and that way it always has the associative properties that you would expect. Again, you don't see that up here. If we go to the model environment, you'll see then that we have the one component is out of date warning, right? So if we click on that, give it some time to load, and we can kind of see that it extended a little bit, right? So zooming in here, we can start seeing too that the models are now extending past the stock, right? Again, it's not what we want. So let's go ahead and move them into place again. So let's select these two, move copy, drag them up a little bit, And then this one is colliding or interfering with this other component. So again, we also need to move it a tad bit. Move copy. And that looks good to me there. Okay, so what happens to our cam toolpath? So like, we didn't spend a lot of time on it, but I mean, that's still a process that we don't want to repeat. So we do have these exclamation points. If we go to the setup, and click on the setup, what we can do then is regenerate the toolpaths. And I mean, granted, if it was a major change where maybe you lost one of the flanges and maybe there was a huge change to the model, maybe you might have to come back in here and reselect some of the profiles. But really, if it was just a small change, like a height change, that shouldn't be an issue for regenerating the toolpaths, right? So here we can right away see that it automatically regenerated, and it handled that that height change without any issues. Right, and that's really what we want to focus on and highlight is having something like this, right? A complete CAD CAM package. It's always going to have that reference, or it's always going to be able to link those models that you create. And again, having that connection to the CAM environment, you can always just rapidly go in there and regenerate some of the toolpaths and give you an updated G code for that. Right. So again, let's go back into our presentation here. Again, that's pretty much all I had to show. It was a pretty straightforward presentation, but again, like I mentioned, it was something that a lot of people have been requesting in our surveys. So again, if there's something that you want to see, stay till after the webinar and fill out that survey, right? Let us know what you want to see next, or a topic that you want to see next. Okay, so Robert, hopefully I answered your question, Robert. The same thing would apply with wood. So like I mentioned, instead of using this sheet metal component, this would actually work a lot better with a wood component, right? Because again, you don't need to flatten it, or you don't need to create some sort of a unfold for this component. You can just remove all the joints that you had, and there's a quick video on that add-in actually that shows a wood assembly getting placed into a specific sheet size. So if that's something you want to see, just go into Fusion 360, type in nesting, and you'll see that video kind of pop up there. And then Greg is asking if I could have used a rectangular pattern. I could have actually. So I can actually pattern this specific toolpath, right? So let's say I wanted to pattern this, maybe 3 or 4 times upwards, right, or in the Y direction. I can do that, right? So I can go over here to select the toolpath, select pattern, linear pattern, right, and then kind of give it some sort of a spacing for it, right? So I can flip the direction, and I'm not sure what the spacing here is going to be, so let's just give it, I don't know, 10 or 12, right? So you can do something like that, and then maybe you want to reposition this one, right? But again, you can pattern the toolpaths. If you didn't want to pattern the toolpath, you can also pattern the component. Right, so you can also just do a rectangular pattern for the component, and then do the same thing that I did here, and it's going to automatically pick up the outer edges. Right. Let's see what else. So we have another question here, right? So someone wants to see a cone. So I guess that's something that a lot of people have a question on. Actually, is a sheet metal cone. You can do those. It's a little counterintuitive on how that works. But I can show, just kind of a quick and dirty way of doing it, right? So I believe I showed this also in the last webinar, right? So again, you just want to create some sort of arbitrary line. You would want to dimension this based off of, if you have some sort of max and min diameter, you can definitely do that. But for now, I'm just going to do a quick arbitrary angled line. I can go over here to the sheet metal environment, create a flange. And then give it a small thickness, right? In this case, I'm just going to say 10th thou is going to be fine for me. And now I want to go back into the model environment. I want to go ahead and look up for the revolve command. Which profile? It's going to be this profile. The axis is going to be the z-axis. I don't want to cut. I want to make sure that I join it, and I want to do a 359, right? Otherwise, if I try to go back into the sheet metal environment and unfold this, it wouldn't unfold because, again, it doesn't have some sort of a rip or tear in there, right? So go ahead and click OK. If we go back into the sheet metal environment, go to Modify, Unfold. Zoom in here a little bit, select the face that we just used, click OK. And then that creates our pattern, right? We can refold it, and then it creates that cone, right? So again, you can make it a little bit taller here and make it an actual cone, and kind of go from there, right? Okay, so with that, it doesn't look like we have any more questions. Again, it was a pretty straightforward webinar. Let me just check the other spots here, make sure we don't have questions here. Okay, yeah, so it was a pretty straightforward webinar. Hopefully you guys learned a thing or two. Again, let us know what you want to see next, right, in our next topic, and we'll do our best to accommodate and create a webinar for that specific topic. But with that, I'll see you guys on the next one.